As you're getting started, closures can be another mind-bending topic in JavaScript, but they don't have to be. If you understand them, you can really unlock the power of JavaScript. Now, having said that, personally, I don't rely on them very often when I write code, but I'm not a JavaScript ninja, so your mileage may vary. You're going to see a lot of articles and tutorials out there that talk about closures, and I think sometimes they make things more difficult than they really need to. So I hope to provide a really simple explanation that will simplify this topic for you, and you can get into some of the more advanced stuff a little bit later on. But basically, a closure allows you to associate some data with a function and then use the function with that data already kind of baked into it from that point on. In my mind, it's kind of like this. I'm basically taking a function and I'm marrying it to some data through an input parameter, an input argument, and then they live happily ever after in their own variable. And from that point on, they work together as a team. Whenever I want to invoke that function with that data already pre-filled, I guess you could say, into the input parameters, I can call that new variable. All right, that's all it is. And then, well, okay, there's more to it than that, but for the most part, that's all there is. So let's just create a really simple example or two, and hopefully it'll clear some things up. So let's create a new file called closures.js. And let's start with just a function. I'm going to create something super simple. Say hello. And then inside of here, I'm going to return a function, because that's kind of the point of this. And it'll just say howdy. And I guess we're going to pass in a name. So howdy plus the name. All right. All right. So that's really step one. I create a function that returns a function. Looks like I got a little problem here. Whoops. I return a function. There we go. So here's the function. Returns a function. And I'm passing in a argument called name that I'll ultimately use in the body of this return function. All right. So then I can actually make a call. So for example, let Bob equal say hello and passing in Bob. Now from this point on, if I call Bob, well, we'll see what happens here. Node closures. All right, howdy Bob. All right, so by itself it isn't all that impressive, but that's really kind of step 2 and 3 all in one shot. So I can pass in some variable that slightly modifies the way that this return function operates. So in this case, it's pretty simple. I'm passing in a name, and it will change what gets printed out every time whenever you call this function in the console.log. All right, so this value is basically saved off in a variable outside of the returned function. So we're relying on how scoping works in order to get that closure behavior. That name kind of follows along this return function everywhere it goes. Bob gets passed along from that point on, and then this is step 3 where I save that off in its own variable so that I can call from that point on, and I kind of get this say hello with Bob pre-filled, right? So I can do the same thing with Conrad say hello, and then Grant say hello. And that's all a closure really is. So let's do those. And there you go. 3 versions of the same function that get returned. We modify the operation by taking advantage of how scoping works in JavaScript, by kind of giving it this value that it's going to hold in its own context from that point on, stored in these separate variables. All right. So this is really just the binding process that binds these together and then stores them off. That's all it really is. So another way to look at this, the say hello method has finished executing and it returns a function, but in the environment in which the method originally ran, it preserved that so that whatever value we passed in is preserved inside of this return function. The environment, or in this case just the name input parameter, this variable name, remains available. So now in step 4, I guess you could say, if there was a step 4, I basically use the new variable, which represents a call to the method, and a preset input parameter to conveniently call that version of my function now. All right. So the important lesson to take away is that each closure creates its own what's called lexical environment, and you'll see the term lexical used a lot in JavaScript whenever you're learning about scope. I've tried to steer away from that term because I feel like maybe it clouds the issue a little bit. It's basically just a fancy word for everything that we learned about in the scope basics here previously, where if you define a variable outside of a function, it is available inside the function, but if you define it in a child code block, essentially it's not available outside of that child code block. So that's basically what I mean by lexical scope. It basically defines how a parser resolves variable names and functions when they're nested. And the word lexical refers to the fact that lexical scoping uses the location where a variable is declared within the source code to determine where that variable is available from that point on throughout the rest of your code. So nested functions like we have here in our say hello that returns a function have access to the variables that are declared here outside of it, as well as any of the input parameters that are declared outside of it and outside of their original scope, right? And that's just how the lexical rules work, like we learned about in scopebasics.js. So when we create a closure, each closure gets its own lexical environment, meaning that they get, each time we create one, like we do here in lines 8 through 10, they get their own set of variables, their own name variable, and anything else we were to define outside of the function. In this case, we don't have anything else. And there's more to closures. You can get in some pretty advanced scenarios. They're a powerful concept in JavaScript. The ability to retain or bind to the lexical environment of the variables that enclose the returned function, like in lines 3 through 5, to create a version of the function with some values already pre-applied is pretty powerful. Now, if you don't completely understand that, that's okay. Don't get discouraged. For now, just understand that whenever you return a function from a function, you also glue any of the variables that were defined outside of the return function, including, in this case, our input parameters. All right? That's all you need to know about closures. Well, for now, anyway. All right, so let's continue on in the next video. You're doing great. See you there. Thanks.